made the recent horrific mistake of upgrading my machine from Ubuntu 23 whatever to 24. And now nothing works. Absolutely none of it works. Virtual environment in Python, totally broken. No idea why. This isn't hard. VNs used to work. Different version of Python. Can't find the old. I'll figure it out. It's just so. Given that you can't take a working machine and just upgrade it, which is really just copying new files on it. Like, all computing is just files on a disk. I hate to break it to people. It's really all it is. Files on a disk plus calculation. That's it. It's the whole thing a computer does. Right? That's why they used to be, until about 10 years ago, stable. Right? You could, every time you put the same inputs, you get the same outputs. All the time. It doesn't happen anymore, which makes the computer useless, by the way. Useless. It's no longer a useful device at the point at which it does that. Now I understand why people like containers, because you're building from scratch each time, for the most part. But the fact that you have to do that is a problem, right? Because you've pushed the instability of the future on the infrastructure in the past. And that's actually way worse. It's way worse because there's way more problems at the infrastructure level that need to be solved than there are problems at the don't break your code level, because you could run a test and make sure it was never broken when it was released. And this is a deep problem. I've had this discussion hundreds of times with people. I know you're not testing your product because it doesn't work. And people are always argue. I mean, I say it that simply. And people always argue with me. And I'm like, no, you can be 100,000 billion trillion gazillion % sure that you didn't test your product if it doesn't work. Like, that's what testing prevents. That is the purpose of testing, period. It's definitional. And people are like, no, we unit tested it. Unit testing is worthless. Don't ever unit test your code, ever, under any circumstances. Unit testing was made for a specific time and a specific place. It's 4 times as much code as you just have to write the thing, right? So you write it once, now you write 4 times as much code, and you have a bunch of unit tests, and your software still doesn't work because unit tests can't test integration, they can't test runtime, they can't test data, and they can't test infrastructure. Almost all of your bugs and all of your security problems are infrastructure and data related. That's it. They have nothing to do with the source code. Nothing. Not all of them, almost all of them. And you just look. You can just look. Oh, it's a misconfigured server. Oh, somebody made the password on an internet connected machine that, and I've talked about this before, this happened, right? Major corporation on an internet connected machine that happened to not have been scrubbed. So the SSH port was open, and the developers happened to have opened allow root login from SSH, which is normally by default, obviously set to do never do this. And nobody checked it, even though they had a security team. Fire everybody in the network team from the VP down, fire everybody in the security team from the VP down, rehire. Maybe you rehire some of the same people, but rehire. Like, re-interview everybody. Get rid of the management entirely. They didn't do that, by the way, but whatever. This isn't that hard. People just don't want to buck up. Yeah, the person you hired sucks. Fire them. Get somebody competent. They aren't competent. We've trained too many people to program, and now we have fewer and fewer competent programmers on average, and more software projects that are doing exactly the same thing. No value, just a waste of time. So I understand why you want containers, because rebuild from scratch. And look, that was my solution in the Windows 95 days, right? I would just rebuild the machine every month, literally. I had scripts and everything, and just burn the disk, format, start the install over, take about an hour and a half. I think I had it down to. Do that. Go do dishes, clean the house, come back, bang, machine's right back where it needs to be. All the data was on external storage anyway, never a problem. Not a big deal. That was a long time ago. Yep. That could be done. Windows XP, same thing. Yep, that could be done. You don't need containers for that, by the way, at all. Like, it's just an extra layer that now you have more stuff to manage. More stuff to manage means more opportunity for error and more code to maintain. So don't do that. Just build it right the first time, and then you don't need all these bazillion other stacks of tools. No, really, it's super simple. It's super great, actually. It's fantastic. And when I used to build self-healing systems, they never ever broke again ever till they were shut down, ever, because it's self-heal. It's actually not even remotely difficult to do, right? But the first thing you have to do is reduce the number of tools you're using to something manageable, right? And then you have to know how those tools break and how to fix that breakage. Sometimes, look, the fix is reinstall the package and rerun it from scratch. That's fine. And if you can integrate that with a floating infrastructure, and cloud is a floating infrastructure, although you can do floating infrastructure without, quote, cloud. And you can argue all floating infrastructures are cloud, but I don't even argue. I think it's wrong and it's irrelevant. You can build self-healing systems that actually always give you input to output. It's not no errors, but it's 100% correctable errors. 100%. It's not actually that hard. I've done it dozens of times. Dozens. It's just not difficult. But you have to use a small enough set of tools. And you, as a single individual on the project, have to know enough about those tools to make them stable. That is not easy to do. And most people cannot do that. I understand that. And you can make the argument that if you had a competent team that could work together, you could do it as a team, and that would be 100 times more likely. I totally agree. But adding new tools and new technologies and Terraform on top of AWS tools, on top of Puppet, on top of Chef, on top of whatever other ridiculous tools, when you already have Salt Stack and it can do all of that all by itself, and Bash, right? Or just using Bash. I mean, geez, the infrastructures I built that did what cloud does before cloud with Perl 4 and Bash, light years ahead of anything you guys have. Light years. Today, now, still. Why? Because we lost the tech. Lost technology, we lost the ability, we lost it all. Lost it all. Now we're just playing catch up. We're playing freaking catch up. I worked for a Fortune 500 company. They did some ungodly millions of tests per night. Every night. Every night. I think we got it down to 8 hours. On every platform, we had 14 platforms. Actual platforms with different physical binaries in most cases, not in all cases. Some of the code was POSIX compliant under Unix. But yeah, there were a lot of platforms. And this worked. And in fact, the QA team had nothing to do. Why? Because the code got QA'd by the integration tests, which are running tests. Like build the software right from code and run it, and then run an automation script on top of that, right? So the QA team at that company, all they ever did was find like little tiny errors in the UI, which is very useful and you need that, right? Like, and whatever. But like, there were no code errors ever. It almost never happened because they tested everything. Millions of tests, right? I mean, millions of tests per platform, right? And times, I think it was 16 or something, including Windows NT, including Linux for a while. Yeah. And it can be done. It has been. That was the 90s. Just saying, that was the late 90s, early 2000s. And you guys can't even do that anymore. Can't even do that anymore. Lost. Completely lost. I walked into one place. They were doing, what were we doing? Millions of, well, potentially. It was a banner ad company. It was potentially millions of connections per minute. And this very early days of AWS. They didn't have CloudFront or any of that nonsense back then, or CloudFormation, whatever the hell it's called. They didn't have any AWS tools. It was a very young project, AWS. So I used Bash. I used images. You know, their little AMIs. AMIs are great. I used pre-built images. I had 3, right? One for each tier of the application. Because you had a front-end tier of the application, you had a mid-tier of the application, back-end tier of the application. That's it. It's not hard, right? I mean, you may need 4, you may need 5, maybe 6. I don't know. You can't, almost certainly can't use 1, by the way. Unless you're just a crazy web app. Like, fair enough. But like real applications, you can't use 1 tier. You need at least 2, probably 3. 3 is the minimum for almost everything. You do 4, 5, 6, whatever. For environments, right? Your dev environment, right? QA environment, staging environment, production environment. Everything else is Bash and Python. Everything. And only because they have this nice little thing in AWS, as far as I know, they still have it, right? We could pass a small thing into the AWS to get things started when the machine starts up. It's a nice little window into the VM. Well, it just so happens that if you connect your VMs to a common directory and they know what they are, and I did this through naming because it was easy. Right? I already have names, so just use names, -QA or QA machines, right? And UI machines are named UI dash, environment dash number or whatever name is given. It doesn't really matter. Just to denote what environment it's in, what type of machine it is, what tier. So if you match the name to the AMI, right, then it can connect to a script that reads that information and installs the right packages. That's it. And now you don't need Puppet and Chef and, although I did use SaltStack. SaltStack is fantastic. But you don't need CloudFront. You don't need any of that stuff. You don't need any of it. It's just rewriting that, which you can write better with more flexibility and more certainty and better testability and better reliability and better consistency in Python, in straight Python. Or Perl 4. Don't use Perl 5. Perl 5 is garbage. I know you can't get Perl 4 anymore. It's a joke. That's all you need. You don't need Golang and Rust. You don't need any of that stuff. You don't need any of that stuff. And in fact, in production, you should be running as close to binary as possible. And the thing that's the quickest and easiest to spin up is always an image. Always. So you put as much common stuff in the image as possible, and you leave as much stuff for install, or as few things for install as you can, right? So you're not installing a lot of things. You spin up and you get rocking. And for 90% of my stuff, the spin up time was so much lower than anything you guys have today. Anything. To be fair, I'm a freak of an optimizer. I will take kernel modules out, anything to get, a half a second. Anything. And in that project, we went from an unstable between 12 and 30 connections per second to 100. And I'm being a little bit generous to myself, but I saw 100 a lot, so I'm just going to count it, even though I should probably count it at 98. But whatever, I'm going to call it 100. That's a big jump. Now that jump was facilitated by a 1% increase in connection efficiency. One thing is, when you have a lot of connections, and do a 1% increase on the connection itself, everything gets sped up. Like the speed to connect gets sped up only by 1%, but the speed to disconnect actually gets sped up more. And that drops the total time spent in connection. And when you drop the total time spent in connection, drop the latency back to the PHP app, to the PHP system, right, which drops the PHP latency, right? So now the thing with a change at that layer is that it makes everything more efficient by an order of magnitude, or 10, right? Or something. Depends on the thing. In this case, it brought us roughly from 12 to 100, right? Roughly. But also the scaling in AWS that, because you still need the AWS. You don't need the AWS. I wasn't going to write my own scaling engine. I've done it before. It's a pain in the ass. I wasn't going to do it. AWS had perfectly serviceable scaling engines if used correctly on super efficient machines. The AWS scaling now worked. Didn't work before because there's too much latency. And so it wouldn't sense the load problem because you got to sense the load problem and then you got to react to it. Well, if the load problem ramps up too slowly, right, then it's too late if your spin up time's too long. But if you ramp linearly because your machine's super efficient, the scaling algorithm has no problem with that whatsoever. And the scaling algorithm doesn't need a linear progression, but it almost guarantees scaling algorithm will work perfectly every time. And so that's a huge advantage to the business. Huge advantage to the business. The only problem was I over-optimized the machines effectively. And because they were so optimized, we were running more machines than we needed for our load on a regular basis. But we were doing that to make sure that if any zone or any region went down, we would lose nothing. And so the machines were very overpowered for what they were, not very overpowered, they're about 30% overpowered for what the load was per machine. But also we dropped the cost because before that we were using way more machines. So I dropped the bill by about 45%, which for a small company is a big deal. Well, it should be a big deal for any company, but probably the big companies don't care. But yeah, 45%, which wasn't too bad. I was hoping for 60, but you don't always get what you want in life. Understand why people like containers. But wouldn't it be better if we didn't break things? Like if VMs actually worked the way they used to work, by the way, because I know they used to work this way. Wouldn't it be better if pip just worked? Wouldn't it be better, right? Wouldn't it be better if these things just worked the way they used to work, the way they're supposed to work? And then you wouldn't need all of the other tools that you need to learn in order to do something simple, like not break your computer by upgrading. Which never happened before, to be fair to Ubuntu, but also Ubuntu's a piece of garbage, like absolute garbage. Everybody there should just commit suicide in the shame of the crap they're creating. It's such trash. The boot times in Ubuntu, I still haven't figured them out. I'm like, what are you doing to boot Linux in this amount of time? My router boots in 45 seconds and is fully functional. Granted, again, I'm a crazy person. I tuned the ever-living crap out of the damn thing. 45 seconds, though. And there are embedded devices that don't boot in 45 seconds that do, to do what my router does. And I mean, everything's up. I got a web server on it. I'm doing BGP routing on it. I got everything on it. Like the thing is, it's way overpacked for it's actually an i3 for some crazy reason. I thought that was a good idea. I do have to upgrade it someday. If you want to give me some money, I'll upgrade my damn router. It's not on the budget right now. I get it. I understand why you want to rebuild everything, but also, what are you doing? Why not just fix the broken thing? And then you don't need all this extra infrastructure. Things could be easy and simple. And then you could spend your brain power on something more important, like addressing the meaning crisis. For more on that, see Navigating Patterns.